Okay, so welcome to part 2 of current electricity. So in the first video, we got the first learning intention. We will learn how to measure current, voltage and resistance. That was kind of done, okay? And that was kind of it really for there. In the keywords, we got electricity, conductor, insulator, voltage, current and resistance done. So we're kind of left with really circuit power, LED and Ohm's law. Okay, so let's see how far we get in this video. So we're going to start today at Ohm's law. Okay, so your heading there, guys, is Ohm's law. Now the definition of Ohm's law is quite long, okay, and it's this: at a constant temperature, the voltage is always proportional to the current in a circuit. Okay, now there's actually quite a lot here when you read into it a little bit. Okay, the key bit here at the start: at a constant temperature. Okay, you have to mention that. Now the reason you have to mention it is that as the temperature increases, the resistance will change. Okay, so if the temperature goes up, the resistance will go up, and if the resistance goes up, then the current and the voltage no longer become proportional. Okay, so they're all linked, right? So they're linked to the temperature. So as the temperature is constant, okay, so at a constant temperature, voltage is proportional to current there. Sorry, not circuit, to current. Okay. Now what that means is basically you will get a straight line graph, okay? In other words, if I increase the voltage, say by 2 volts, the amp should go up by 2 amps, and the voltage goes up by 4 volts, then the current goes up by 4 amps, okay? In other words, they go up at the same rate. That's the idea here. So take down that and your definition, okay? As you can see here, this means if the voltage increases, the current will increase at the same rate, okay? Now, take down this. This means in a circuit, if we divide the current by the voltage, we get a constant, okay? We get a constant. And what is that constant? Okay, that constant, okay, is the resistance. You can actually find the resistance from it, okay? So the constant would be your resistance, all right? So this means in any circuit, if we divide the current by the voltage, we will get a constant. Now this is important for, I think in junior cert, they might not ask you to get it, the resistance using the slope equation, but usually you get the slope from the graph, okay? All right, we can find the resistance caused by heating elements in a system by dividing the voltage by the corresponding current value. So let's take down those 2 points there, the definition and a bit about the constant if you divide the two, okay? So this is kind of what Ohm's law looks like. Now we didn't get to do this before lockdown, all right? But generally you would have your power pack, okay? And then now we won't have resistance in water. I have variable resistors, which kind of work just as well. So you attach your voltmeter in parallel and your ammeter in series, okay? So the voltmeter is always attached to parallel, so if you remember that when we did back with the packs, okay? So this is kind of your diagram of it, okay? So you'd have your resistor, your unknown resistor here. You would attach your ammeter and your voltmeter in parallel and in series, okay? So the ammeter is always in series, it's always in one after the other, and your voltmeter is always in parallel, it's in the parallel circuit, okay? That's the way it's always done, okay? Now, Ohm's law, okay, you would draw your circuit like this. So you'd have your current down here and your voltage up here, okay, and you would get, this is what it means by proportional, you get this straight line, okay? So straight line means it's proportional, okay? So just be aware of that, okay? Straight line is proportional, okay? Now, under the same heading, take down this bit here. By getting the slope of the graph, you will find the resistance caused by the variable resistor, okay? So that's what you do. You get the slope of the graph. The slope, if you remember, it's in the log tables, y2 minus y1 over x2 minus x1, okay? Now again, if you look back to what we did last video, okay, resistance is voltage divided by current, you see? So take out resistance, you voltage divided by current, R is equal to V over I, you see? And when you get the slope, you're going to have your voltage over your current, because voltage is on the y-axis, current is on the x-axis, you see? That's why the current is on the x-axis, voltage on the y-axis. You'll end up with your equation, R equals V over I. That's how you draw your graph. That's why you get the slope. You're basically just using this equation from the previous video, you see? It's just you're graphing it now, that's all, okay? Now, all right, so that's kind of what's happening there. Let's get that rubber to work again. There we go. All right, so take down that point there. By getting the slope of the graph, you will find the resistance caused, okay? And then after, go back and watch this link here on the bottom. All right, so that's kind of Ohm's law. It's the basic kind of thing of Ohm's law. All right. Okay, so let me see what video 20. Okay, yeah, so it will have to be 3 videos. That's it. Okay, so we'll do this down until we get to power, and then I think we'll leave it then after that. I think power will be its own video. Power will be very short, then it'll only be maybe 10-minute video. Okay, so circuits. There are 2 types of circuits used in everyday life. Okay, so the 2 circuits we're going to do. So your next heading, guys, is circuits. Okay, and the first one is a series circuit. So there are 2 types: series and parallel. Okay, now you made them back when we did with the circuit packs before lockdown, before Christmas. Okay, well, we'll refresh it here now. Okay, so what is a series bulb circuit? It is when 2 bulbs are connected one after the other. Okay, all right, so 2 bulbs are connected one after the other. All the current coming from the battery goes through both bulbs. Okay, and then of course there is an advantage and a disadvantage. The advantage uses less electricity. And of course, the disadvantage, if one blows, the circuit is broken, no current flows. Okay, so take all that down. So in a series circuit, everything is connected one after the other. The current that comes through the battery goes through everything. Okay, the advantage is you use less electricity, so it's cheaper to run. The problem is if one of those things breaks or goes, everything goes. Okay. All right, so just write all of them down. And that's kind of what your series circuit would look like. As you can see here, the power, the current has to go through absolutely everything. Okay. Okay, so our parallel then is your next heading. So your parallel circuit is your next heading. Okay. So bulbs are connected parallel to each other as opposed to side by side. Okay. Take down that. Bulbs are connected parallel as opposed to side by side. All right. The difference here is the current coming from the battery splits up and some goes through each bulb. So the current gets split. Okay, so the current gets split. So some of it goes through one bulb, some of it goes through the other bulb. Okay, and if the bulbs are the same strength, you'll get the equal current going through each. But if the bulbs are of different strength, then the current is different through each bulb. Okay, so of course, again, your advantages. So advantage, if one goes, there will be a complete circuit through the other bulb, so it remains lit. So if one bulb goes, everything stays on. Okay, the second advantage, less resistance. Okay, so the first advantage is if one thing blows, the others will stay on. Okay, whereas in a series circuit, if one thing went, they all went out. The second advantage, there are 2 advantages, is that there's less resistance. Of course, the disadvantage uses more electricity, so it's more expensive. Okay, so take all that down, guys. You need to know that for your parallel circuits. The advantage, if one blows, the electricity would just flow through the other circuit, so we're fine, and there's less resistance in that circuit. The disadvantage, it's more expensive because you use more electricity. Okay, and this is what your parallel circuits will look like. Okay, so as you can see here, the power goes through, and when it gets to our parallel circuit, it divides. Okay, it breaks off into 3. All right. And that's what parallel is. In other words, they're connected one above the other. And the reason for this is that if this bulb went, the electricity would simply flow through the other 2. Okay, that's what we mean there by that. All right. Okay. So let me see, we're on 10 minutes. We might actually get this video finished. Okay, so electrical components. Okay. So electrical components. In one picture, the bulb lights up, but not in the other. From the diagram, can you tell what's the difference between the 2 of them? So you have 2 pictures here, A and B. Okay? So, any ideas? Well, what we do is follow the diagram. This is an actually exam paper question as well. Okay, so this is kind of the exam paper question. Just let me move that. There we go. Okay? So, see the arrow here? It's telling us which way the current is flowing. All right, so it's coming from the positive, going down through, going through here, going up and going back. And the same over here, down, through, going in, up and back. The difference is the bulb is lighting here, but it's not lighting here. And what's the only difference, can you see? It's these things here. See the arrow. Okay, so if we look at them, okay, look at the arrows, all right? In A, so if you look at A, the arrow is pointing in the same direction that the arrow from the current is pointing. And if you look at B, the arrow is pointing backwards against the arrow of the current. So what's happening there is that they're called forward and reversed biased, okay? So this one is, so in A, it's pointing in the correct direction, you see? So the current will flow through, it's going with the arrow, okay? Whereas in the second one, in B, it stops, it's hitting the wall. You see where in front of the arrow there's a little line, okay? So if you imagine it, that's a wall stopping it. So the current now can't travel through. So that's what's happening. So A will light up, but B won't. So with the diode, it has to be pointing in the same direction. It has to be going plus to minus, okay? See here, it's going minus to plus, and therefore it won't work, okay? So the diode always has to be pointed in the right direction, okay? So your next subheading, so that's your heading there, but then underneath, just a little light, is diodes, okay? And draw in a picture of the diode. So draw in this first. This is your picture of your diode, okay? So draw on that as well, just so you have an idea as to what we're talking about. It's just a circle with a triangle and a little line in it, okay? Now, so a diode is a device, so quite a bit to take down here. So a diode is a device that allows current to flow in one direction only. So a diode is a device that allows current to flow in one direction only. Okay? That's key. So, if the positive end of the diode is connected to the positive end of the battery, it is called forward biased. Okay, so take that down. So if the positive end of the battery is connected to the positive end of the diode. So as you can see here, or in this picture here, the positive end, there we go. The positive end is behind the battery, you see. So here, the positive end is here, and the negative end is here. Positive end is here, negative end is here. So positive to positive, so that's forward. Okay, so that's a forward biased. Okay, and the last point, if the negative end of the battery is connected to the negative end, to the positive end of the diode, it's reverse biased. So this is reverse. Okay, so A is forward biased, B is reverse biased. Okay, and that's how you do it. All right, so rub that out. Okay, so take down those 3 points. You need to take down everything here. Okay. So you need to take down everything here. A diode is a device that allows the current to flow in one direction only. If the positive end of the diode is connected to the positive end of the battery, it's called forward. If the negative end of the battery is connected to the positive end, it is called reversed. Okay? It only flows if it's connected in forward biased. Okay? Alright. So yeah, you should have all that taken down by now. Again, pause the video, guys, as you're writing. Okay. So this was an exam paper question this year. Okay, I think it's from the old course, but it could be asked in a new course as well. Similar kind of questions, really. Now, you don't need to take this down. Just look at it, read it, and then try and answer it. So, to show the action of a diode, in the diagram on the right, current would normally flow in the anti-clockwise direction. Okay, so the anti-clockwise direction. All right. In this case, however, the current will only flow through part A and not through part B. Can you explain why? Okay, now I think in the exam, if I'm remembering correctly, the question was which would light up, A or B, okay? But in this one, anti-clockwise. So basically, guys, with the battery, they'll usually tell you that's the plus side of the battery, that's the negative side of the battery, okay? And anti-clockwise, so again, we'll draw a quick 12, 6, 3, 9. So clockwise is this way, so anti-clockwise is the opposite. So anti-clockwise here, guys, means it's flowing this way. Okay? So when you get to here, you have A and B. So the electricity is going to try and go up this way and back. And as you can see with A, it's forward biased. So A is forward biased. The arrow is pointing the same direction that the current is going to flow. But B is reverse biased. It's pointing in the opposite direction. So the electricity won't flow here. So B won't light, but A will. Okay? So that's what's happening. All right? So A is forward biased, so it will flow through, but B is reverse biased and it won't flow through. Okay? You have to keep that reverse biased, forward biased. Okay, I know it's a higher order question, but still it's important to know. Okay, so we're at 15 minutes, so I think we'll do the last thing here, which will be an LED. There's 4 slides on that, and then we'll leave that for part 2, and then we'll do part 3. Okay? So your next heading, guys, is simply just LED, okay? So it stands for light emitting diode. So LED stands for light emitting diode. So LED, light emitting diode. So LEDs are similar to diodes, but they emit light. So that's the difference, okay? Similar to diodes, but emit light when current passes through them, okay? So take down those two. I mean, LED stands for light emitting diode. They've taken off now, they're everywhere, especially some cars now have them as their light source. Basically, they're more efficient than a regular bulb. They last longer, they use less electricity, and they're just as bright. Okay, so that's why LEDs have become revolutionary in lights, basically. They're similar to diodes, but emit light when the current passes through them. So the diode won't emit light, it just lets current pass through them, but these ones do. So the question here, don't need to take down the question, but think about it for a second, see, can you figure it out? Do you know the answer to this? How else would they be similar? How else are LEDs similar to diodes? And when would an LED light up? So think back to diodes. Do we know? We'll go back to diodes. Okay, so because they're a diode, it'll only flow in one direction. So LEDs will only allow the current to flow in one direction. Okay, and like diodes, okay, they need to be forward biased to light up. You see, so when will the LED light up? It has to be forward biased. And there you go. Okay, so because they're diodes, current will only flow in one direction, and they'll only light if it's forward biased. So take down the first 2 points there. LED stands for light emitting diode. They're similar to diodes, but they emit light when the current passes through them. Okay? So as you can see here, which bulbs would light up when using an LED? So that's the symbol for an LED, by the way. Okay? Oops, I don't know what happened there. It's basically the symbol as a diode. It's the same symbol as a diode, but you have two arrows coming off to indicate light. That's what the arrows are for. So these little arrows, they're to indicate it's giving off light. That's all. Right? So if I was to make, let's say, this the positive terminal, this the negative terminal, which would light up, the red or the green? Okay, so let's follow it. The electricity would flow this way. Okay, let me rewrite that better. Okay, so the electricity would flow this way. That's the way it's going to flow. All right. So which one, red or green? It's going to be red. Okay, because the arrow is pointing in the correct direction. This one is reverse biased. You see, so this one is forward. You see, so that's a forward biased. No, the D didn't come out there. That's a forward biased diode. Okay, and of course, if I swap the terminals around, I make this positive and this negative. So now the power is going to flow this way. Which one of these will light up? Well, it'll be the green, because now the green is forward biased and the red is reverse biased. You see, so always follow the arrow, draw your line, see what way the current is flowing, and see that the arrows match it. That's it. Okay. All right. So from the above circuit diagram, note that in both circuits the current flows in anti-clockwise direction. Note that both circuits the current flows. Oh yeah, don't worry about it. The LED is turned on around and around. No current will flow through the new circuit. No light will be emitted. That's fine. That's self-explanatory. Okay. Next thing here, guys, is this one really. How and where to use LEDs. Okay. How and where to use them. Okay. So key things here, lads, there's a bit to take down here. LEDs use a small current. So they rely on a small current. They need a resistor to protect them. So all LEDs, now most of them come pre-made. Well, the ones in school anyway have a small resistor attached to them anyway. So the resistor is to protect the LED. Okay. So too high a current will blow the resistor or blow the LED. Okay. Now, LEDs are primarily used as indicators in electronic circuitry, okay? And modern diodes can give out a lot of light efficiently, okay? Less energy lost due to heat, okay? So a lot of light efficiency, okay? So it's increased efficiency. So a lot of LEDs now, guys, are very, very efficient. That's why a lot of modern bulbs, they're moving away from CFS bulbs, and they're kind of going to diode bulbs. Okay, you can see them there, that there's many little small little dots on them. Okay, they give out a good amount of heat, light. I nearly said heat there. So they give out a huge amount of light, but not an awful lot of heat. And that's one of the main losses of electricity in bulbs, is that they give off too much heat, but LEDs don't really do that. Okay, all right, so take down those 3 points there. And we'll go back to our learning intentions. So where are we here with this? So our learning intentions, that was done in the first video. We learned parallel series circuits. That has been done. Build circuits that test LEDs, diodes, LDRs, and a thermistor. So we did before school closed, we got most of those, an LDR and LED, but we don't have thermistors, so we couldn't test that. And Ohm's Law we did today. So let's look at this. What is a circuit? What is electricity? What is a conductor? What is an insulator? What is voltage? What is current? What is resistance? What is an LED? What is Ohm's Law? So the only thing that's left in the next video is power. So we've nearly everything done. We've the learning intention is done, and we've most of the keywords. Okay, so that's it, guys. This 20-minute video. That's part 2. Part 3 we'll do next, and we'll focus on power and LDRs and finish it up. Okay. If you have any questions, guys, leave it below or in the Teams page.